Hey, good day folks. Today I'm looking at using SQLite with Zig. Now, I did previously blog about this, but it's been a while and I used an older version of Zig. So for context, I'm using Arch Linux for my desktop and I'm tracking the software in the Arch Linux repository. Now, they have a recent version of Zig in the repository, but it's lagging a little bit behind. It's not the latest version of Zig. Now, there are some changes in the latest version of Zig that I want to start playing with, specifically the way that C imports are working. So they moved C imports out of the code into the build system. So we're going to be playing a bit with that. And in today's exercise, what I'll do is I'll rewrite the example code from the SQLite website in Zig. So our first step is to make the terminal session use a version of Zig that is different to the version of Zig that's installed through the Arch Linux package manager. Now, what I did off camera is I already downloaded the tarball with the Zig executable that I'm interested in. So we're going to start by extracting the tarball. Now, inside the tarball, we've got the Zig executable. It should be statically linked without any dynamic runtime dependencies, but we can verify that. Okay, the executable is as I expected, and we can just use it by overriding the path for our terminal session. Now we can test that this terminal session is using the version of Zig that I'm expecting with the which command. Okay, everything's fine. Our second step is to create the build system from a minimal Zig project. To create the minimum Zig project, we run a Zig init with the -m parameter. Okay, all this is doing is it's just creating the build system files for us. Now, to make autocomplete in the editor a bit easier, I'm going to create some stubs in the file system. So the c.h file is where we'll have all the include statements for the C headers. So that's no longer in the Zig code. And the main.zig is where we'll have the code for our main module. Okay, now with the build system, we need to start by getting our target and optimization options. Okay, now that we've got the standard parameters, we will create our C translation unit. And the root source file is that header file that I created. and we want to link the SQL system library to the C translation unit. Next, we will create our executable. So the root module's source file will be that main.zig that we touched in the terminal. It's going to have the standard optimize and target as well. And we want to import the C translation that we created. Now, when we run the build step, we want the executable to be installed and not a temporary cache file that can be lost. Now, something that would also be useful is if we had a run step that can just run the executable immediately after the build. So for this, we're going to start by defining the run command. And the run command will be dependent on the install step, so that there's an actual executable on the file system that it can use. Okay, now that we've got the run command, we need a run step. And the run step will be dependent on the run command. Okay, now the example that we're rewriting in Zig expects some command line arguments. So we do need to take the command line arguments to the build CLI and pass that on to the executable. Okay, that should be the entire build system. Now I'm just going to do a test. I do expect this test to fail because we haven't implemented any of the code. But I need to the correct failure to appear there. If it's a failure in my build system, then I need to fix that first. Okay, and this is the failure that I expected. We don't have any main functions in our empty stub that we created. Now, to verify that everything's working correctly, what I'll do is I'll implement a Hello World application inside that stub main that I created earlier. Typically, we start by importing the standard module for the standard Zeek functionality. Then the main function need to be public. One of the things that are new to Zeek 0.16 is that the main function now have an init parameter. Now, for the Hello World, we're not going to use the init parameter. And we just can use a standard debug print to print the Hello World message. Okay, let's give that a go. And there we go, Hello World. Okay, so our third step is to open a database. So for this, I'm going to look at the example C code and I'm going to rewrite that in Zeek. But before we jump into the main module, we just need to update our C header file. Okay, and what we need to do here is we need to include the SQLite header. Okay, as far as I can tell, we don't need to add any pragmas or if not defines to avoid multiple includes, but I'll still need to play with this a bit more. Okay, and then we need to import the C translation module. Cool. Let's look at the example code. Okay, so what we're doing is they check that there are 3 arguments because they expect a particular use case. And then they go ahead and open the database and close it if things are not right. Now, in the example code, they use integer returns to indicate fail or success status. We can use Zeek error types, but just to make things easy, I'm going to stay more true to the example C code. Okay, so this needs to be a U8 because technically the return type of a C application is in the range from 0 to 255. So in terms of our first item here, the arguments, we can get the argument list from the init parameter. And then the fprintf, I'm just going to replace with a standard debug print. Okay, the formatting string is also going to change a bit. So instead of %s, I'm going to use s inside curly braces. Okay, so the second part here is to open the database itself. So what has remained unchanged is that we can just do the module dot and function name. Okay, we've got a DB parameter, which would be okay. Now, if we read the SQLite documentation, what they say there is that the open function may return a database handle even if it has a failed return code. So we would always need to close the database once we've called open. Okay, so we need to check that if the return value is not equals to success. Again, the fprintf is just going to be replaced by standard debug print. We can make the same change to the formatting. We don't need to call close the second time because this defers can run whether or not the command failed. And then if everything's successful, we're just going to return 0 because that's the success indication for C applications. Okay, so let's try it out. Okay. This failure is expected because we didn't supply the correct parameters. So let's supply 3 parameters and check that it's working. Now the way to supply the parameters is we need to use this dash dash after the build instruction. Okay, everything passed. Let's look. Okay, there's our test database as well. So it created the database and then closed it when the application finished. Okay, we're now going to look at rewriting that callback from the C example code in Zeek. So let's just have a look there at the example. Okay, so we don't need to do anything special for the static. Anything that's not public will be limited to the scope of the module anyway. The integer return type, that's going to be just a cint. Okay, then we just need to add the function signature definition to this. The first parameter is unused and it's a void pointer. So the Zeek equivalent for that is an optional in-your-page. Then we've got the argument counter, and this is just going to be a C integer type. Okay, third parameter here is the arg values, and that's a 2-dimensional C array of chars. So the Zeek equivalent of this, we've got a way of indicating that something's a C array with the star C inside the braces, and it's 2-dimensional. And the Zeek equivalent of a char is a U8. Okay, then the next parameter is the column names, and that's again a 2-dimensional array of chars. Cool. Now the last thing we need to do here, we need to tell Zeek that this must use the C call convention. And that has to do with the ABI compatibility layer, because we'll need to pass a function pointer into a C library. So this function need to follow the conventions of the C execution style. Just add a comment there for better formatting. Now, the next part here is we just need to convert this boomer loop into the Zeek equivalent. Now, the R counter is a C type, so we do need to cast it to the Zeek size type. Righto, so the printf we're going to replace with just a standard debug print. Okay, now we've got a problem here. Zeek doesn't have this trinary operation that we get in C. Now the way that I'm going to solve it is I'm going to call two different print debugs depending on whether or not that arg value is null. Okay, and we don't necessarily need this last printf, so I'm just going to remove it. So that's the callback function. Let's just do a compile check before we move on. Okay, all good. Okay, nearly done. So the last part is to put everything together and to execute instructions on that database. So let's look at the C sample code. Okay, so what we're doing here is we're calling the SQL execute function, and then we check if there were any errors. Okay, so we can now change that RC value from a constant to variable. Let's check here. That's all good. We've got the callback function implemented. That just need to be a regular null. We've got this error message, which okay, so that's a pointer to a character, a string. Okay, let's move on to the if statement. So just need to add the .c prefix. Again, the printf we're going to replace with just a standard debug print. And the formatting strings different. Okay, so then we've got this free function that we need to call on the error message itself. This is just a stylistic preference from me, where I do prefer to always use a defer when I have to call free or close operations. Righto. So that's everything. Let's give it a test run. Okay, now it says syntax error with hello. This is a failure, but it's expected because we didn't give it a valid SQL instruction. So let's give it something value. We want to create a table. And yeah, let's just populate big int values inside it. Okay, so it's created the table. If I run the same thing again, it should fail. That's the way we expect it. Now we can insert some values into this table. Of course, there we go. So now if we run a select on the table, then we should be able to see our value that we inserted. And if we insert more values, we're going to see a different entry for each row in our table. Cool. So that is it. We are done. So if you've made it this far, thanks for sticking around. This video was certainly much longer than what I expected. If you want to see the code or read the blog, I'll add some links in the description of this video. If you like the video, click on the like. If you want to see more, click subscribe. Otherwise, I'll see you next time. Ciao.